Well, hello everyone, and thank you for coming, and thank you, Maggie. I really enjoyed that. I'm fairly new here, so I thought I'd use my first couple of minutes and my first few slides to introduce myself. I think what the seminar team would want me to say is one of the great things about these seminars is that we do get to know each other, we work out each other's backgrounds, areas of expertise, and we can work out who we need to go to if we need help. So my name is Dave. I'm a research associate in the Policy and Innovation Group here in IES. I'm a local. I grew up not too far from here, just the far side of Arthur's Seat, near Portobello. I went to Portobello High School, which you can see here.
Can you speak up a little bit, please?
Sure. I went to Portobello High School.
Two of us.
Yep, great place, but it'll be gone soon, demolished soon, hopefully. I did my undergraduate here as well, back when the School of Informatics was based just over in JCMB, which is a bit longer ago than I'd care to admit just now. After I graduated from my undergrad, I did the kind of stereotypical middle-class graduate thing. I went travelling for a while. This is the route I took. So it took me 7 months and covered a fair bit of ground. And when I got back from that, all I really wanted was to find a job that would let me keep travelling, or help me keep travelling even. So I found that in the oil and gas sector. I moved into what's known as oil and gas sector marine seismic surveying. So working at sea, working on vessels like this was one of my vessels. And the idea with seismic is we drag a lot of recording equipment behind us. We go over a survey area for typically 6 weeks to 6 months, as hired by various oil and gas companies. And roughly every 10 seconds for those 6 weeks to 6 months, we set off a very loud explosion. Absolutely constantly, 24 hours a day, 7 days a week. And we record those reflections with this array of hydrophones that we drag behind the vessel. This would typically be about 1 kilometre wide and 8 kilometres back, the array of hydrophones. And what we're trying to do is find and characterise oil and gas reservoirs. So while I was on the vessels, I led the geophysics department, and our task was to create the final product. So we take the recorded data, we clean it up, get rid of noise, get rid of extraneous data, and we output products like this. This is what goes to the client, and it's what they use to analyse and assess whether they want to do test drilling. So I did seismic for 7 years. I loved it, but eventually I'd say guilt crept in. I'd had enough of the oil and gas industry. I did still want to be involved in the marine sector, and I decided I wanted to be involved in marine renewables, in particular wave and tidal. So I looked around for a course, and based on the reputation of Edinburgh's marine studies, I signed up for the SES Masters here. I did that in 2013-2014 when Sasha Jokic was leading it. And towards the end of that year, I signed up for a dissertation with Henry here and Laura Finlay, both in policy and innovation. And that was at the beginning of DTOcean, actually. So this formed part of the background research for the initial days of DTOcean. I was looking into how we can design installation and operations procedures for large-scale marine arrays. So taking what we know about installing individual marine devices and taking what we know about installing large-scale wind arrays and looking into what knowledge can be transferred between the two sectors to form a framework of guidelines for developers planning much larger arrays than have ever been installed before. So after graduating from SES and after a little bit of time recovering, I went off to work for the Carbon Trust. I started with them in their London office, working in the Policy and Markets division. And while I was there, I was working on a project that was gathering and synthesising a lot of future energy scenarios from various research institutes around the UK. And we were really looking to find a consensus view of where the UK energy system is going in the lead up to 2050. After finishing that project, I transferred up to the Edinburgh office around about the time Wave Energy Scotland was first kicking off. And the Carbon Trust had won the contract to help with the initial design of the Wave Energy Scotland programme. So while I was there, we ran 2 competitive calls, the power takeoff call and the novel device call, which has just been announced in the last week, actually. One of my more time-consuming tasks there was we also have in our hand all of Polanis's data. everything Palamas had on their systems when we went under went to Wave Energy Scotland and then ended up at Carbon Trust and has actually ended up here with us now. But a time-consuming task is digging through that data and trying to find out what might be useful to us. And finally, just as my contract at Carbon Trust was coming to a close, I was lucky enough to find and be offered a position here in the Policy and Innovation Group. So that's a group that's led by Henry here. We also have Sam, Laura and Adrian working in that team. And a couple of weeks ago we were joined by Jonathan Hodges, who will be doing business development for WES through us. Here's a sample of just some of the projects we're working on in that team at the moment. DTOcean, which we'll speak about in a minute. Lean Wind, which looks at lean logistic functions for offshore wind. Wave Energy Scotland, I'm lucky enough to still be able to keep in touch with through Henry. And we also hold positions on the European Energy Research Alliance and International Energy OES, Ocean Energy Systems Initiative. So we do a lot of project work for them as well. And well, that's quick enough. That's enough for me, I think. So we'll move on to the advertised topic of today, the DTOcean project, which is a project I'm spending roughly half my time on now. DTOcean is optimal design tools for ocean energy arrays. And what we're looking to design over a 3-year project is a suite of open source software tools that will guide developers or really anyone who's interested in it in forming optimal array infrastructure designs. So we're not looking at optimizing devices, we're looking at optimizing everything that supports the device in becoming a functional commercial array. The overall goal is, with everything we do in this department now, to accelerate the industrialization of marine energy. And in the case of DTOcean, when we see marine energy, we're talking about wave energy and tidal stream energy. When we talk about optimal, what we're really saying is we want a competitive cost of energy from marine energy, we want it to be reliable, secure source of energy, and we want an acceptable, even a good environmental impact from our operations. So DTOcean is operated by a large consortium. We head that consortium, we coordinate it from here in Edinburgh. We've got 18 partners from 11 countries, almost all in Europe, although we do also have Sandia National Laboratories in the States, who were interested enough in the project to bring their own funding in order to be involved. We've aimed to have a real breadth of knowledge and expertise from across the marine industry. So we've got, of course, academic institutions like ourselves, University College Cork and Aalborg. We've got utilities and project developers, so companies like Iberdrola and DEME Blue. And finally, we've involved a lot of supply chain companies because they bring real-world expertise. They've actually been out there doing this stuff already, installing cables, installing moorings and foundations. So we've got companies such as Prysmian, IT Power. Right, I don't know what's... There we go, perfect. We're funded under Framework 7 of the European Commission Research and Innovation funding. Roughly €4 million funding comes our way from that. We also have our Strategic Advisory Board, which is formed of some of the most influential voices in marine energy, representatives of organisations like the ETI, standards bodies like DNVGL, Atlantis Resources, who operate Maygen, are also involved. And their task is really to keep us on track and make sure that we're meeting the needs of the industry. So, well, this isn't the most exciting picture to look at. It's not the most colourful, but the way DTOcean is structured is into 7 distinct work packages. So we have 2 upfront work packages, which give us the scope of the project. The scenarios tell us what kind of technologies, what kind of arrays we need DTOcean to be able to deal with when it's finalised. And the array layout, based on hydrodynamic analysis, gives an initial start point for all the other work packages to work from. So a good idea, initial idea of where each device in the array will be set. Following on from that, we've got 4 content-oriented work packages. So we deal with electrical infrastructure, moorings and foundations, installation procedures, and operations and maintenance procedures. Throughout all of these work packages, we have cross-cutting themes, so economics, environment, and reliability. And that tells us that everything we do in the other work packages, we always need to keep these in mind. We need to keep in mind the goal of low cost of energy, high reliability, acceptable environmental impact. And finally, we have an integration work package. And the task of that is to take the optimized solutions from all the other work packages and play them off against each other and find an optimized array lifecycle level solution. So we're not talking about simply an optimized electrical infrastructure. We're talking about the entire array for the entire lifetime of the array. That work package is also tasked with providing a user interface and documentation for the system. So we'll quickly go through a bit more depth of the individual tasks we're undertaking, the individual work packages. So we have 4 validation scenarios. So they guided us in deciding what functionality we wanted in DTOcean, but they'll also provide the system by which we validate the software at the end. These have changed a little bit since the start of the project as projects come and go. We were lucky recently to be able to bring Majin in as one of our scenarios. That's through access via the Strategic Advisory Board and also through another project we run called Clearwater. Our array layout, we have 2 very different functions obviously, one for wave, one for tidal. Based on hydrodynamic analysis, gives a start point, a good idea for all the other work packages of where we would like to place our devices. So we have here an example of the outputs, test outputs of this package as we try and fit more and more devices into the lease area we're allowed. Our content-oriented work packages, we start with electrical system architecture. This is tasked with, first of all, selecting the best components for within the array. So that can be anything from static cables to dynamic cables, connectors, collection points, all this kind of thing. It also has to define how we connect the array to the grid position. So that will involve selecting the best transmission cables, ratings, types, and even the number of cables for larger arrays. And finally, given bathymetric data and geotechnical data, this work package has to work out where we want to place the cables, what the optimal, most cost-effective route to shore will be. Our moorings and foundations package takes the output of electrical system architecture and array layout and combines it with geotechnical data provided by the user to work out what types of moorings and foundations we want and where we want to position them. So obviously we're looking at foundations for fixed devices, moorings for floating devices. As kind of a side project for them, they also have to define the geometry for any lazy wave dynamic cables that are specified by upstream modules. And then again, following on from them, taking everything they've learnt from the previous modules, the installation module has to work out how we can most cost effectively, safely, and with the lowest environmental impact install everything we need for this array to take off. So that involves defining the individual installation operations, but also finding the optimal sequence of operations. And a lot of their work is based on defining the port and vessel infrastructure we require for this. And our final content-oriented work package is operations and maintenance. So this really focuses on ensuring that throughout the life cycle of the array, we optimize the power takeoff of the array, we optimize the output of the array. So like I said, we have these cross-cutting themes, but it's worth noting that operations and maintenance really ties in very heavily with our reliability theme at this point. And taking that data, they define the most useful maintenance strategies and maintenance schedules for us. So speaking of the cross-cutting themes, our first one is economics, and we define optimal in this case based on levelized cost of energy, ELCO. So as a very basic representation of our ELCO model there, we're talking about yield, capital expenditure, and operational expenditure. And our metric in this case is euros or cents actually per kilowatt hour based on the entire array infrastructure. Reliability we wanted to focus on as a big part of DTOcean is ensuring that we provide that we aid the attractiveness to investors of an array. And in terms of security, investors are going to need to see a reliable solution. So we're looking not only at component failure rates, but we need to work on how failures in individual components can impact on the rest of the array, and in turn how that will go to impact on ELCO. And finally, we can lower the cost as much as we want, we can raise the reliability as much as we want, but we don't want to do it at simply any cost to the environment. So based a lot on input from the developers, we're looking to find solutions that are acceptable in terms of their environmental impact. We're never going to have a zero impact infrastructure, but we can certainly minimize it. And that kind of brings us to what we have done, and we'll move on to progress now. So our individual work packages, we're getting close to finalising the functionality. We've done a lot of testing on the functionality of all of these. And as we move into our final year, our third year, the real task is tying them all together into a single package that we can distribute, that developers will find useful. And the challenge here is making sure that we're not finding simply optimal electrical infrastructures or moorings or foundations, but playing these off against each other and finding that balance so that the overall metrics offered by the array, so the overall cost, reliability and environmental impact, are the best we can offer given various solutions from the individual work packages. We have a piece of software called the core, which does this optimization routine, or will do this optimization routine, and is also tasked with providing the communication between all the individual work packages and the user and the database of predefined data that we supply. As we get towards the end of this year, the other task will be getting it into a usable format for the user. So having a fully integrated graphical user interface where the user can see results, work out if it's to their needs, make any changes and request reruns. So the user, it's important that the user is able to redefine certain aspects of the array if they need to and find new optimal solutions based on those changes. Probably one of the more boring tasks we have to face this year also is providing documentation so that people understand how to use the system. And that's pretty much a very quick introduction to DTOcean. It's a large project, it's a 3-year project with a lot of funding, so a 15-minute intro is not covering a huge amount of it, but I think we're all very happy with where we are progress-wise. We're pretty much where we're meant to be 2 years into the 3-year project. As Henry likes to say, this is now the fun bit where we get to tie it all together and see if what we've been doing for the last 2 years is useful, if it's giving us good results. I don't think the coders in Technalia agree that this will be the fun bit. So I think we're a couple of minutes ahead of schedule, but I'll be very happy to take any questions or comments, and then you can get back to your day.
This production is brought to you by the University of Edinburgh.